So this is our newest rocket. It's called the Eliminator. And before we send this up, hopefully in the next couple of days, I just wanted to go over a couple of key features about it because it's a really neat rocket and it was a really fun build. The wild paint job is based on an item found in a video game. I'll show you a picture of that right now. You can see I've loosely based the paint job off of that image. So first off, the body tube. This is a 3-foot long section of 4-inch diameter cardboard shipping tube. This is available at any office supply store. It's inexpensive and it's nice and strong material. So that's that. The fins are made out of an 1/8 inch MDF paneling board. It's a little bit flexible but pretty rigid. I really like working with this material for the fins and for some other parts like spacers and motor stops inside the body tube because it's really easy to shape, and because it has no wood grain, it has no weak spots or splintering problems. Now this nose cone is my own design. If you've watched my video before on a foam-filled, resin-covered nose cone, this is not that style. So hopefully I'll have a chance to put out a video on how to make this. It's actually really easy, and it's a very nice nose cone. It has a really slick glass finish on it. So inside we've got a nylon parachute. This is a 36-inch diameter, 8-cord parachute. I've switched materials on what I'm using for parachutes now. This is the liner, a shower liner. When you buy the inner portion of the shower liner, you can get it in 3 thicknesses. There's basically lightweight, medium weight, and heavyweight. This is the lightweight material. It folds up nicely, and it's a good material. It's a little bit heat resistant, or more heat resistant than thinner plastics would be, so the blast from the ejection charge doesn't affect this nearly as much as thinner plastic materials. Inside here we've got the electronics bay. We're using the Altus Metrum Easy Mini flight computer. It's an altitude or an altimeter sensor. It's in charge of logging the flight data as well as it ejects the parachute at apogee. Now to handle the actual ejection itself, since sugar motors don't have an ejection charge built into them, I build these little ejection charges. This is a 1/2 inch CPVC cap, and it's got a little hole drilled in the side of it, and one of these electronic matches just goes into that cap. In there is just a small amount of black powder that's then sealed over with some hot melt glue, and then this little soda bottle cap just gets hot melt glued onto the top of that. And that's really just to protect the inside of the rocket body and the parachute and the cords from the blast. So that just kind of helps contain that a little bit. And this cap sits right underneath the nose cone. So when it goes off, that gets blown off and pushes against the cap or against the nose cone. You do end up losing this cap because it blows out at altitude, but it's just a soda bottle cap, so that's easy to replace. You do have to be real careful because black powder is a very powerful product. There's very little of that in here, and if you do use something like this or similar to this, you need to do some ground testing to make sure that it's strong enough to eject your nose cone but not so strong that it blows things apart. This is the motor that we've developed for this particular rocket. It's a Flexi fuel cell motor. It has 4 fuel cells inside. It's 1.25 inch PVC, and the fuel area is a total of 12 inches long. This is our 4th generation nozzle assembly. It's an all steel convergent nozzle and divergent assembly that drops into the PVC and gets secured in when you glue the motor together. It's really nice because it's reusable, and it's very dependable because there's no deterioration during the burn. So that comes out really nice. We've tested this motor a couple times in ground tests. This will be the first rocket that actually uses it for a launch. So at the bottom of the rocket, we've got an adapter sleeve that fits into the rocket body, and then up about 11 inches there's another ring that the motor will slide into as well. So when the motor is fully installed, it will stop right there at the end where the ring is a little bit bigger. So it sticks out of the rocket just a little bit. Hope you enjoyed some of the information about this rocket. This should be a really fun launch. We'll get this up in the next couple of days, and the next video we post should be the launch video for this rocket. Thanks for watching.